Alright, we are going into the third charge of my e-bike, and we're at 46 miles. On the first charge I got 19, so 27 miles on the second charge so far, and it's still going, so that's significantly better. You know, after around 18 miles on the first charge, the bike started like surging and running kind of weird. I think what caused that was that I had charged all the batteries individually. I hadn't done a balanced charge, and I might not have them charged the same. So one of them had probably slipped so low in voltage that it was in like a protection mode where it was, you know, shutting off power for the battery, causing that surging. That's amazing. 27 miles and going. I think I'm just going to charge it again where it's at, but let's check some voltages. Okay, so I'm going to go ahead and disconnect my battery from all these series wires that I have. So these four leads are the battery. 14.68 volts. Wow, there is a lot of charge left on these. Man, about this one, 14.66, 14.67, 14.67. Wow. Okay, what's that mean? I need a calculator. I'm too dumb for this. But basically, you know, my battery pack, each one of these modules has a couple 4S3P modules in it. Whatever I'm trying to say. And so typically the low voltage cutoff is around 3 volts. So 4 in a series, 4 times 3, 12 volts. I still have 2.5 or 2.6 volts of battery left in these at 27 miles. Maybe I should just keep riding and really push it down lower. Okay, I'm going to check. There's a relationship between battery voltage and the charge percent of your 18650 lithium ion cells. So, you know, 100% charge is 4.2, 0% charge is 3. Probably, you know, to extend the life of the battery, you don't want to go all the way to 100 and don't want to go all the way to 0, right? So if you remember, my batteries were at 14.65. You divide that by the 4 cells in series. That means each cell has an average of 3.66 volts in it. And according to this chart, that means there's about 10% capacity left in this battery. And since I don't want to go all the way down, maybe 5% of usable range left at 27 miles of throttle only motorcycle style bike riding. So maybe I could push this to 30 miles range, but that's pretty exciting. The other thing I calculated real quick is charging at 16.5 volts means I'm only bringing each cell up to 4.125 volts, and that would be somewhere between 90 and 100%. 90% is at 4.06 and 100 is 4.2, so maybe I'm at like 97% charge or something when I go to 16.5 volts. But that's all great news. That's very exciting. So how I charge these is following the instructions printed on these BB-2590 batteries. You know, so it says charge each 12 volt section independently, which I'm not doing. I'm charging all 8 sections of these 4 batteries together at once at 16.5 volts consistent voltage with a 3 amp max. That means each one of these batteries, you know, when you have the 2 modules in series, can do 6, so 24 amps total, I guess. And charge is complete when current drops to below 100 milliamps. To allow charging to proceed, separately apply a 5 volt DC through a 470 ohm quarter watt resistor between the charge enable contact and pin 6. But the other interesting thing to note about this battery is it says the BB-2590 has a self-discharge rate of about 10% per month, thus ensure a fresh charge prior to missions. So these are military batteries. And I guess I take my bike on road warrior missions at 30 miles an hour through the streets. Anyways, yeah, I just charge following more or less following the rules printed on these batteries, and I charge outside because I am pushing it a little bit, charge them all together because it says not to do that. Well, let me just show you how I do this stuff. And so I disconnect the series cables, and then I've built the second one of parallel, so I can hook up all these batteries in parallel. Allows me to charge them with the power supply that I have, because it only goes up to 30 volt. I can only charge them each at 16.5. That's just a limitation of the equipment I have. So the first step is I hook all the batteries up in parallel, and then the next step is I have to supply the 5 volts with the whatever it was, the 40 ohm resistor to activate the charge circuit. So each one of these packs, as I built it, has a resistor in line underneath this shmoo, and then I built a wiring harness to connect them all together to a 5 volt power supply, which is just a USB power supply. So let's hook that up real quick. And so here's my charge activation circuit. Boom. So now I'm hooked up to my charger. So this is a really cheap, like, lab power supply, $30 off of Amazon or something. And so these leads go to the positive negative of my batteries, and then this one with a USB goes to turn on the charge circuit. It's got a 5 volt regular USB power supply. So first thing I'm going to do is I'm actually going to disconnect it right here, and I'm going to turn this on, and I'm going to check my voltage. So I guess let's go down a click, 16.5 volts, and then I'll plug that into my battery, and it's already starting to charge. So as I'm putting nearly 5 amps into it, I mean, I can go all the way up. Whoa, it only will accept. Oh yeah, okay. So this thing has a max of 10 amps at 30 volts. I guess it maxes out at 9.71 amps at 15.4 voltage. But I mean, this battery pack can take as much amps as this thing can put out. Just for the sake of the power supply, because it is so cheap, I just keep it more around. Where are we? Come on. I keep it around 5 amps. Just because it doesn't get nearly as hot putting out 5 amps as it does trying to put out 10 amps. So we have the voltage. I'll go ahead and unplug it again. The voltage is set at 16.5 continuous voltage, and then when it's charging, I'm have it set at max out at 5.145 whatever amps as it slowly raises the voltage. And charging this takes forever at 5 amps. I mean, all day. You set it up, and it might not be done by the time bedtime happens. And typically, if I get a late start charging it, I'll just turn it off, and I'll start it back up in the morning and finish it then, because I don't quite feel comfortable with this yet to just leave it unattended. And I don't know, but whatever. So that's my current charge setup. I probably should replace this with something a little bit more robust that can put out some more amps, and I could feed these batteries a little quicker. a shopping lesson at Battery Hookup. So when you buy your batteries here, make sure that you buy as many as you need for your project, because you never know after they sell out if they're coming back or not. So, for instance, the batteries that I bought, the BB-2590 batteries, these guys right here, I bought them, I don't know, 6 months ago or something. I bought 5 cells. I needed 4 for the project, 1 extra just to, in case one was bad. They were dirt cheap. You know, they were $11.69 each or whatever. And they come with a BMS and this and that. And they're, you know, a military grade battery. You know, they come with a little label on them that says not for javelin use. And I scratched my head on that for a while, wondering what javelin was. But it turns out a javelin is a anti-tank missile. So you can't use these batteries in your anti-tank missile thing. So keep that in mind. But anyways, so you know, they sold out of these, and then a couple months later they came back. Plus they had some used ones, and then they sold out of all of them again, because this price of $11.69 per new module turns out to be insanely cheap. And so everyone just scooped them up. So I mean, look at this. So new, $405 each for one of these batteries. And then even, you know, used on eBay, you know, what, $50, $75, some of them as high as $150. I mean, that the battery hookup price was just, it was nuts. Just know that it was nuts. And so they sold out. They got more. They sold out again, and so now these are unobtainium for the sweet price. But back to, you know, when you're shopping around, these, I mean, there's just so many options. Every time you come here, there's some new, great, amazing deal. And I don't know, you know, an e-bike battery is easily $400 or $500 if you buy it. And you just think about what you could do, like 36 volts, 48 amp hours for $250. I mean, you could run, I don't know, 150 miles on this. Like, that's insane. That's insane. For $250, you could like replace your car with an electric bike if you wanted to. And, you know, and then look at this one here. For $50, you can get 6 amp hours at 48 volts. I'm doing air quotes. Can you hear that? Or look at this deal. 48 volt module, 6 amp hours for $40. Run, you know, 2, 3, 4 of these in parallel. Just the point of all this is just make sure that you actually get the amount of battery you want up front, because you just really never know when this stuff is going to sell out or come back. If you just buy one little module as a test and then you come back, next thing you know they're sold out, and then what are you going to do? Just like never have a project for that one little module again. So in the world of the BB-2590, there is some hilarious things about it, because they're a military battery, and for whatever reason, there's all these comic strips. You know, it's update your battery charger software. It's like, time to charge you guys up. Did you make sure the charger software is current? Yeah, last thing we need around here is another fire. It's like, one recent fire caused $5.5 million in damage. Make sure that your charger is up to date so you don't burn down your warehouse or your military base. All right, so even though these are like military grade batteries and they're awesome, you know, they're just as flawed as any other battery, I think, is what we can learn from this little comic thing here. When I first bought these batteries, I wasn't sure what I was going to do with them. I was looking into some stuff so you can buy a charger specific for these batteries for real cheap off of eBay. You know, some battery charger in a box and just charge them the normal way. And then there's all the plugs and adapters for this stuff. Let me open a picture. So these meld connectors, you know, $15 each, 4 batteries. You know, you spend more on it than you do the battery from Battery Hookup at least. But then you could have all these just like plug and play things, and you could I don't know, swap batteries out, make a case where you can pull the batteries out and have, you know, like I thought maybe I'd buy, you know, 8 or 12 of these batteries and just cycle through them and charge them at home and then just swap them out into my e-bike. But then you know, the reality sunk in that I wanted to do this for as cheap as possible, and that's when I went a different route where I just got out my soldering iron and I filled in all these leads. I soldered wires into every little individual lead on these things, and just rigged up a wiring harness for my own personal flavor and style of how I do things. So I got onto Battery Hookup, and I bought these new old stock lithium ion cells from, you know, their army surplus, right? And I started watching videos and trying to figure out what I wanted to do, and I decided, you know, I got on that Jehu Garcia channel, and he's moved from tearing down, you know, packs to trying to figure out how to use them directly. You know, like, why redo all the work that's in one of these, or a scooter pack, or whatever he has to sell. Because he has a website called Jag35. It's just like Battery Hookup. It's just different sides of the continent here. And so anyways, like using, you know, learning to use these packs as they come. And he got me. So I've decided to build a wiring harness instead of a whole you know, e-bike battery. So I bought these to go with this kit because it said they were, you know, 12 volt times 2 each. And I was like, oh, that's awesome. You know, that's exactly what I need. Blah blah blah. I'll do whatever, get it going. But then I started learning about how 18650 cells actually work. And so a 4S3P module, you know, it's 4 in a series, and 3 of those series in parallel. So the nominal voltage of the particular cells in these batteries is 3.76. So if you multiply that, you know, by 4 in a series, you get 15.4 volts, right? And then if you're going to use, you know, try to step that up to match a 48 volt system, it's not as easy as just going 12 times 4. It's actually 15.4 volts nominal times 4. So it's, I was going to make you know, I guess I'm making a 60 volt battery is what I'm saying, long story short. I took this one apart and I looked at the MOSFETs, and they're rated for 70 volts. And then the 2 main caps on it were rated for 63 volts. And that's pretty close to what this thing is going to run. These batteries have instructions on them to charge, and it says charge at 16, you won't be able to read that, charge at 16.5 volts. You can see that line right in the middle there, 16.5 volts. So let's just do a little math real quick. Okay, so the full charge is 66 volts. The nominal is 60 volts. Discharged, the data sheet on the cells in these batteries said discharge is 2.5 volts. So 2.5 times 16 in a series is 40 volts. What I'm wondering is, the only thing that I could find inside this controller that isn't rated for 66 volts is those capacitors. And the capacitors are rated for 63 volts. So we have a 3 volt difference when it's fully charged. So it just means when you have a fully charged battery that we're going to be pushing those capacitors to the limit. Then when under the nominal charge and below nominal voltage, it's going to be okay, right? Am I going to blow this up? I don't think it's too big of a deal if you destroy your motor controller, because these things are pretty cheap. You know, these cheap Chinese ones are like 30 bucks on eBay from an American warehouse. The wiring diagram right here. So one 15 volt nominal section is pin 1 to 4, right? And another 15 volt nominal section is pin 2 to 5. And if you want to make it 24 volt, you jump pin 2 and 4, and then you use pins 1 and 5. Let me make sure we're on the right ones. We're on pin 2 and pin 4. You jump those, and then see 32. So you get 32 volts that way, and without the jumper, you get 16.4. 15.4. Huh, am I learning new things? 16.4. Oh yeah, because these are charged. Duh. Okay, see, I'm already being stupid. I was like, why is it higher than my nominal voltage? Because these are charged. Duh. I mean, okay, so obviously we have a situation where it's the blind leading the blind here. But the plan is, I think I'm going to use short little 16 gauge jumpers. I'm going to just solder them into these little fittings, and then I'm going to use these XT60s, and I'm going to have an XT60 for each module inside this pack, and then I will I'll do it that way, so it'll give me the opportunity to individually charge these halves if I feel like I need to balance them a certain way or not. The female connector is the one where the contacts are the receiving end. The male connector is the long contacts. And the positive side and the negative side are labeled on both ends, both the male and female. So there's lots of redundant labeling here to help you from making a mistake. So this is what I'm thinking. I haven't soldered these in yet. So I'm gonna have just a few inches, so I can come down and around, plug into things. And then I also need for this particular battery, I have to put a 5 volt with a resistor power to this SW pin, and then here's the negative for that circuit, and that turns on the battery's charge circuit. It won't charge without 5 volt being supplied to SW, right? So I'm going to need that in there as well. I'm just going to have to see how to do it. I don't know. I think there's going to be some melting in my future. Alright, I need some more wire. I don't think I'm going to have enough of this orange wire for my battery, but whatever. It is what it is. Alright, so my little welding setup is ridiculous. I have this ancient rusty Craftsman thing, and so I'm just putting a little bit of solder on the tips of all these. It helps them go in there. I'm just doing a little dip and cover. So what a lot of people do online is they have both connectors together to help dissipate a little bit more heat, and I guess that's a good idea. This iron gets pretty hot, so I'm just gonna grab a little bit more flux, poke in there, roll it around. So I guess you could do something like that. Get that nice and hot. Just flow it in there however you can. That was like totally out of control. Yeah, I don't know. Do that. So this gets pretty hot, so set that aside and do a different one. Let's see if we can do it better. Let's try a different technique. Let's see if we can just put a little bit extra solder on there, and if we can just have it follow it. Yeah, flow in there. Ooh. Yeah, just letting it flow in there like that. That was sweet. I like that. I guess I'll do more of that. All right, flowing these in worked out pretty good for the most part, but this one got a big giant glob on it. I'm gonna nip it off, I guess, but most of these, I mean, that one has a little hole in it from like slag or whatever. That one, you know, it filled in pretty well. So these connectors, they came with some heat shrink, and I have some other heat shrink here. But what I've been doing, or what I did on my first one, my prototype model, I'm doing like a double heat shrink on it. It's sort of like a strain relief. So I'll install the first one there. And you can use a lighter, or you can use a heat gun, whatever. I went to the Harbor Freight and I bought some red heat shrink just to keep it looking pretty. Where I'm going to get my heavier gauge wires is out of an extension cord, and so those don't have red wires in them, at least not the one I'm cutting, and so it's gonna, you know, I thought I would just put some heat shrink on it to keep those wires red, so I can still have black and red. And this red one is bigger, but it'll still shrink down okay. Say that, it doesn't quite fit. So then, you know, offer some level of strain relief to it, and you know, whatever, it makes me feel good. That's what it's all about, right? The heat shrink, that's important. Well, at least I'm saying it is. I'm gonna go ahead and put some heat shrink up here, so I'll be ready to come down. I'm gonna take a little bit of flux. I'm gonna drop those right in there. So I'm going to use the smallest solder I have, so I can have more control over how I do this. Oh my God, shaky. So a fair amount went in there. I could pick the battery up with that if I needed to. So I think that's how it's going to happen. Alright, let's just move all this heat shrink down. Let me go ahead and put a little Alright, I'm working on the charge circuit now, because for these batteries, in order to put voltage in to charge them, you have to put 5 volts through the charge circuit to activate it. And what do they want? They want a 1/4 watt 470 ohm resistor. So what I'm doing is I'm putting a resistor in line, and I'm soldering it to the SW tab. So this is the positive, and then the negative of the 5 volts goes into where I've wired it yellow. This is the very center pin there, right? And yeah. So I'm taking these off, putting that in. The idea, what I'm thinking, is that I'm just gonna zip tie all this stuff together around the base to minimize the flex right here, because it's very thin. You know, I'm trying to reinforce it a little bit with the heat shrink, but really I want this to be kind of immobilized, because I don't think it's gonna last otherwise. And yeah, I know I could have put the resistor in line, the 5 volts, and got everything, but I want these batteries to be standalone also. If I choose, you know, if these don't work out in the e-bike, then I can, you know, have some other little like power wall project or tiny power wall project. But you know, run some stuff, because I do live in Texas, and our you know, grid fails sometimes. I'm just gonna go cover up the whole thing there, and shrink it on. Oh yeah, I chose to go with these little blade connectors, right? So the 5 volts goes through here, so the female end, which is protected, will be the positive going into the battery, and then I put the negative terminal on backwards, so I have the females coming off the battery here, and then the negative blade will go in there. I'll dip the blade on there. Put a little bit more flux right on top. Actually, here's what I'm going to do. I'm going to braze this just a little. Just a tiny little bit. Hopefully it still fits. A little bit big. Let me make it smaller. Oops. I've done that every other time. Worked out fine. And now look at me messing up. Oh my. Let's go a little bit further on. Get hot enough to melt. Whatever. That's just where it's going to be. Oh God, I'm hopeless. I'm so hopeless, guys. Oops, that's not where that should go. I don't want that there at all. Right there. There we go. Got it to fall down where I wanted it. Okay. Cool. Alright, so now I got another little piece of heat shrink. Just gonna push that up on there as far as I can get it, which isn't very far. So actually, I'm kind of tempted to try to protect the nubs. If I take this heat shrink and I push it up right above the nubs, slightly above the nubs, what happens? Let's start here, get to shrink on top of the nub, okay. And how much will the bottom shrink? Yeah, that's probably better. It might be a little bit too much on the blade, but this doesn't really do anything, and I don't need to do this to begin with. I'm just being weird. Let's just reattach this thing best we can. Alright, yeah, there we go. So then on the negative side here, I'm going to do the same maneuver. Dip my wire and flux. Jam the terminal end on. I'll go ahead and brush a little bit more on top. Pick up a little bit of solder. try to absorb some of the heat from it. Okay, cool it down. I'm just gonna shove this little puppy up there, melt that off. Ooh, dog, look at that. Cool. So that's the 4 batteries. I got those 4 done now with the charge circuit a little bit more well thought out, hopefully. So I'm trying to figure out how I'm going to wrangle this wiring harness into submission. What I'm thinking is I need to zip tie these into the position that they're going to ride in, just to minimize the stress on things. So I got these little tiny zip ties. I'm just going to hook a bunch of wires together like this. There may be more zip ties later when it comes time for the actual wiring harness. But alright, so I'm going to fill this whole top of a battery with I'm going to call it silicone. I'm going to use the same stuff I used on my window trim because that's what I have. It's a siliconized acrylic or something, so it's kind of flexible. And the reason for that is I think this is a design flaw in these batteries, is the plastic that the gasket that makes this package waterproof is so thin that it's really easy to break. And the way you know it's broken is if can you see that? Is if this thing moves around a lot. Can you see how that wiggles? If it wiggles, it's broken. So that one wiggles, that means it's broken. That one doesn't. That one doesn't. That one doesn't. But, I mean, this is going to be the top side of my battery. So if any water does get in here, it's going to find the lowest spot and it's going to go in and ruin it. So I don't think I have any other choice besides to do it. Okay, I don't know what got recorded, so I'm using my stuff I used on my siding on my house, right? And I just made a big old glob of stuff. So this stuff is sticky. So what a guy taught me a long time ago, he was a caster. He would make silicone molds of things and cast. So he showed me the trick where you take a bar of soap and a little bit of water, get your finger wet, get a little soap on it. He used ivory soap. This is Caress because I like to be smooth. And it won't stick to a wet soapy finger, and it'll let you shape it without getting it stuck to your finger. So you can smooth this out a lot. And so, you know, it's something. It's a little something, not too sophisticated here. And that looks okay. Where to put my pokey? Holy crap. Might as well put a little right here too. What if I should just fill, I'm going to see if I can fill in this whole thing. Yeah, that's what I'm going to do. I'm going to fill in that whole void. I'm just going to have that whole wire, the whole resistor underneath that pookie. Let's see if I can shape that now. Try to prevent sharp edges so it won't snag on anything. Let's see. Oop, my finger was a little bit wet on that one. Yeah, so whatever. I'm going to roll with that. We'll just let that be that. I'm going to do that a whole bunch of times. Cool. And tomorrow, that should be a nice hard plug, and maybe it will help prevent disaster. And so with that, friends, the simple 40-minute video is how I got these batteries where I could use them. And it was all wiring harness construction and just using these batteries as they came, even though they come with a proprietary BMS. The instructions on how to use them was printed right on the label. So I hope that was useful to somebody trying to use these BB-2590 batteries or building an e-bike or whatever. Please give it a thumbs up and subscribe, and I'll catch y'all later in the next episode.